Hello, welcome back. Today we're going to be talking about areas of triangles and parallelograms. The objective is by the end of this video, you should be able to find the area of a triangle and a parallelogram. So the area is the space inside of a figure, and the first shape we're going to look at is finding the area of a triangle. Now, a triangle has an area that is found by multiplying the base times the height and then dividing by 2. B again is the base, and H again is the height. So if we look at a couple examples of some typical triangles, this one right here, the base would be what I have outlined in blue. The height would be the distance from the tip that runs perpendicular to the base, this being the height. For this triangle right here, the height, we're going to assume that this is a right triangle, is here, and the base would be on the bottom. So let me give you an example of a triangle. We're going to find the area of it. If our base right here is 10 and our height is 5, find me the area. Well, the area is going to be equal to the base times the height divided by 2. 10 times 5 is 50, divided by 2 is 25. Units squared, since I didn't give you the actual unit or measurement of the base and the height. Now we're going to take a look at the area of a parallelogram. The area of a parallelogram is length times width, or just LW, or it can also be listed as base times height. Let's take a look. This first shape is parallelogram. We're going to assume that we know that because all of the angles are right angles. And the length is the distance across. The width would be the distance up and down in this case. Honestly, it doesn't matter which one you call the length and which one you call the width for a rectangle. Now over here, this triangle would be a little bit more difficult, or rather this parallelogram. This is why sometimes we use, instead of length and width, we use base and height. Because we take a look at this parallelogram, our base is this distance here, but our height can be found one of two ways. Our height is either the distance from the tip going straight down of this tip, or the height is from this tip straight down, making a right angle. Either one of those distances is the height of this parallelogram. So what I'm going to do is I'm going to give you a couple of examples. I want you to find the area of the two shapes I show you. Let's say that this is 6 centimeters, and we'll make this one 3 centimeters. We'll make this distance right here 5 centimeters, and this one right here 7 centimeters. Go ahead and find me the area of those two parallelograms. For the first one, we see that our base, or rather our length, is 6, and our height or our width is 3, so we multiply those. 6 times 3, and we get 18 centimeters times centimeters gives us centimeters squared. Now for the second one, our base is 7, or our length, and our width or our height is 5, so we go 7 times 5, and we get 35 centimeters squared. And there you go, you found the area of two parallelograms using either one of these formulas. Now sometimes we're going to be given situations that don't directly give us the information we need in order to find the area. Now taking a look at this problem right here, if you're given the hypotenuse of a right triangle is 25, and the length of one leg of that same right triangle is 7, we need to find the area of the triangle. Best thing to do in this situation is just to go ahead and draw a picture So I'm going to draw a picture. I'm going to say the hypotenuse is 25, and the length of one of the legs of our right triangle is 7. We need to find the length of the other leg. So that's supposed to be right triangle. And we're told that right here, the hypotenuse is 25, and the length of one of the legs. Now, it doesn't tell us which one. We're just going to label one of them 7. Find the area of the triangle. Now, in order to find the area of a triangle, I'm going to write that formula. It's always a good idea to write your formula when working any problem involving areas. So we got area equals base times height divided by 2. You notice we've got the height, 7, but we do not have the base. The hypotenuse is not the base. So in order to find the base, we're going to have to use the Pythagorean theorem. A squared plus b squared equals c squared. Now c always being the hypotenuse, and a and b don't really matter, they're just the legs. So I'm going to say 7 squared plus, we don't know what our base is equal to 25 squared. So we get 49, and actually we can use a calculator for this. 49 plus b squared equals 25 squared. So if you don't know what that is, you can grab your calculator, turn it on, and go 25 squared. And you get 625. So we get 49 plus b squared equals 625. And we still need to get b squared by itself, so we subtract 49 from both sides. So again, go into your calculator, 625 minus 49, and you're going to get 576. So that leaves us with b squared equals 576. So to find b, we still need to take the square root of both sides, giving us, in the end, b is equal to, so we go back to our calculator, square root 576. Again, to find the square root, you go second and then x squared button, giving you 24 as the base. So we know that our base is 24. We can now find the area of our triangle by using our formula. So this is really a two-step process. We had to find the base first, and then we're going to substitute that back into the formula to find the area. So our base is 24 times our height, which is 7, divided by 2. So again, we're going to go back to our calculator, and we're going to go 24 times 7, enter, and then we're going to divide by 2. Giving us a final answer of 84 units squared being our area. And now we're going to find the area of this figure right here. Now, you're going to be given some dimensions. This is a right triangle on top. We're going to say that the base, or the length of this parallelogram right here, is 12. And we're going to say that its height is 9. And we're going to say that this distance right here is also 9. And you have to find the area of the figure. Now, anytime you've got something that doesn't look like any shape you've really seen before, it's a good idea to split the shape up into two different shapes. Now, if we look at this, we've got our easier shape to find the area of, being the parallelogram right here. This is just a parallelogram. And that means our top shape is a triangle. So if we want to find the area of the entire figure, we're going to go the area of the parallelogram plus the area of the triangle. So let's go and find the area of the Well, let's find the area of the triangle first, because that's going to be a little bit more of the difficult problem. It actually follows right in line with what we did previously. Looking at the triangle, you notice that you are given a couple different lengths. The first one is easier to see. The first length that you notice is this distance right here. Now this has to be a leg. The reason I know it's a leg is because across from the 90 is the hypotenuse. So you notice that your hypotenuse length is 12 because it's the same length as the base of your parallelogram. So this is 12. Which means it's just like the problem we just got through working. We have to find the other leg in order to find the area. So we go a squared plus b squared equals c squared. 9 squared plus, we don't know what this right here is, we'll call that b, equals 12 squared. 9 squared being 81, 12 squared being 144. We subtract 81 from both sides, and you get b squared is equal to 63. Then you go ahead and take the square root of both sides, and I'm going to bring out the calculator. And we get that the base is 7.94. So b equals 7.94. This means the area of the triangle, I'm going to do area, is going to be the base, 12, times the height, excuse me, not the 12, the base, 7.94, times, we'll call 9 the height, divided by 2. So, we go back to our calculator, 7.94 times the height, which is 12, oops, excuse me, 7.94 times the height, which was 9, and we're going to divide by 2. Giving us, in the end, the area of our triangle being 35.73. So this is the area of our triangle. We still need to find the area of the parallelogram, which is a lot easier. I'm going to do that in a different color. The area of the parallelogram is going to equal, based on sides, we just go 9 times 12. So that gives you 108. You add those two amounts together, 108 plus 35.73. And you get the final area, which is 143.73. After you add up the area of the triangle plus the area of the parallelogram.